So today we will talk about the weightless satellites. That how satellites become weightless when they go above the earth, like when they go out from the earth, how they become weightless. So for the reason is that the gravity becomes zero. But this is not true. The gravity doesn't become zero. It is not zero. We can say gravity will be present here, but still the this satellite will be weightless. But still we write that the gravity become zero. But if we talk about above the earth, like from out of the earth, there is a strong pull. So weightless actually means free fall. Now what does a free fall means? Free fall means when the body moves towards earth or towards a center with acceleration is equal to 9.8 meter per second square. Free fall, like weightless means free fall. Now what does the free fall mean? Free fall means when the body moves to the center of the earth with the acceleration 9.8 meter per second square. So now we will see that how it becomes. Okay, the velocity by which the satellites are sent out of the earth is known as escape velocity. The velocity which is used for the satellites to send them in the space, send them from out of the earth, is known as escape velocity. The formula of escape velocity is 2rg. So this is the formula of escape velocity, and the value for the escape velocity for the earth is 11.2 kilometer per second. Remember just saying that it is not meter per second, it's kilometer per second, because the speed of the satellite or rocket is very much high. That's why it travels kilometers in seconds. Okay, then let's write this formula more. We know the value of g is equals to g r upon me. G is equals to g me upon re square. So this is the formula of g, right? So we will put this here. 2rg will become 2re gme. This is actually g, this one g, and re square. This will be minus by this, and we will have a formula 2meg upon re. So this will be the formula of escape velocity, another formula of escape velocity. Okay, we will also observe this value too. Like in many MCQs and books, it is written this, and sometimes it is written this. So both are same. You can take any one of them. So the satellites become actually weightless but not massless, because we know that the basic difference between mass and weight. Mass is the quantity of matter and weight is the attraction of the matter towards the center. So this is the escape velocity, is the velocity which is needed by the satellites to overcome the gravitational force and to revolve in the orbit. And it depends upon environment too. The escape velocity depends upon environment too, and no effects on pressure, air pressure, and spinning of earth. It doesn't get affected by these things, but it get affected by only gravity. Now we'll talk about the root mean square velocity and escape escape velocity. This is root mean square velocity. When the root mean square velocity is less than the escape velocity, okay, now it is present, the root mean square velocity is present between the gas molecules. It is present between the gas molecules. When the escape velocity is higher than the root mean square velocity, then the environment exists. But when the root mean square velocity is higher than the escape velocity, environment doesn't exist. For example, in Earth, the environment exists. Why? Because the escape velocity is higher than the root mean square velocity. But in Moon, environment is not there. Why? Because the root mean square velocity is higher than the escape velocity. The satellites which are sent by the NASA and many other organizations are always sent in a 2D direction. For example, this is our Earth, right? And this is the center. It's not the perfect circle, but still, I'll imagine it is a perfect circle. If we are projecting, this is, for example, a rocket or a satellite, right? And just imagine that I'm projecting it like this. It will come here then. But now with greater velocity, it will come here. Soon, with the higher velocity, the curvature will decrease. Curvature decrease. I'm doing more. And now there will be one point when the curvature of the Earth and the curvature of the orbit will meet and the satellite will revolve around the Earth. Like when curvature of Earth is equal to curvature of satellite, when they both meet, so then the satellite revolve around the orbit. As you can see over here, the centripetal acceleration is always towards the center. So for example, this is a satellite. The centripetal acceleration is attracting the satellite towards the center, but its momentum is saying go to this direction. Go to this direction. So that's why here the centripetal acceleration is pulling it inside the Earth. It's in the center of the Earth, and the momentum is pulling outside. Or you can say force will not come. Centripetal acceleration is there, right? So it will move in the orbit, or you can say when the curvature of the Earth meets the curvature of satellite, the satellite revolves. Now we will talk about it. What does the free fall mean actually, and why? Okay, when we know that the formula of acceleration, centripetal acceleration is v square upon r. So v will be obviously the orbital velocity, and radius will be the radius of satellite. Like it will be from here to here. This will be the radius of that satellite. So when we put this value, we approximately get the answer 9.8 meter per second square. Why we get this answer? Because we got this answer because the satellite is not that much far away from the surface of the Earth. It's just far away from the curvature, but still the gravity is pulling it. That's why it's revolving around. So it's not that much high. As you can see there, for example, it's a satellite, but this is a moon. So moon is still revolving. Why? Because of the Earth's gravity. So can't the satellite revolve? But that's why the answer that the centripetal acceleration, the answer will become coming 9.8 meters per second. And we talked about that when the body moves towards the center of the earth with the acceleration of 9.8 meters per second squared, the body will known as free fall, and it means it will become weightless, and it will become weightless, and it will revolve around the earth. So now let's talk about the cases of weightlessness. For example, this is a pulley, right, and it's pulling a box. Okay, and there are two types of weight: the apparent weight and the real weight. The apparent weight which we feel, and the real weight which is obviously, for example, I have measured my weight, which is 40 kilogram. So when if someone is touching me or someone is pulling me up, so obviously the weight will be not 40 kg. He will feel that I'm quite heavy, but that's not true. So that will be the apparent weight, because which is felt by the person who is pulling me up. So as you can see here, that the weight is applying downward side and the tension is applying upward. So they will both cancel each other and the body will become in rest. So here they will not cancel each other, but tension is equal to the weight, which means the tension always shows us the apparent weight because it is acting upward. It is obviously pulling it up. So apparent weight, and this is shows us real weight. So this both, it means that these both will be equal.